there is a large number of very high quality aerospace and space manufacturing companies in Maine. There are a lot of attractive sort of features for a spaceport to be here, and I think that will change the Maine's economy.
That's Ali Abedi, professor of electrical and computer engineering at UMaine, talking about the aerospace industry's potential in Maine. I'm Ron Luznett, and this is the Maine Question podcast. Whether you're a movie buff who likes stories about space exploration, or you follow the actual real-life missions, most of those stories likely starred in Florida, at Cape Canaveral, or in Houston. The state of Maine doesn't come to mind. That's changing slowly but surely. While there won't be manned flights taking off from Maine anytime soon, there is a burgeoning industry in our state, and companies are growing, attracting talent and creating jobs. At the University of Maine, collaboration with NASA and private companies is growing as well, in a variety of projects. One such collaboration involves the deployment of CubeSats into orbit to collect data for a variety of research projects. These satellites are not large pieces of machinery. They can vary in size from several inches long to maybe the size of a toaster oven. But what they lack in size, they make up for in terms of information collecting abilities and cost. Abedi and the students in his lab are constructing and equipping a CubeSat dubbed MESAT-1, that's MESAT-1, which will be launched into space in January, if all goes well. It will circle the globe and send data back for a number of research projects that were conceived, in part, and will be used by schools across the state, middle and high schoolers. Pardon the pun, but this project is just the latest in a series that shows the aerospace industry is ready to take off in Maine. Sorry about that one. In this episode of The Maine Question, we talk about that with Ali Abedi and his PhD student, Joseph Patton, and ask the question, what is the potential of the new space economy in Maine? Thank you so much for taking the time to talk to us. Maybe we just do a quick round of introductions and what you do here so folks listening can have that information. Ali?
Hi, thanks for having us. My name is Ali Abedi. I'm professor of electrical and computer engineering here at University of Maine.
And Joe?
Hi, thanks for having us on. My name is Joseph Patton, and I'm a PhD student in electrical engineering, and I work in Dr. Abedi's lab.
Great. So give us the big picture in terms of satellites. How many are out there right now, and what kinds of satellites, what purposes do they serve?
So there are somewhere between 4,000 to 5,000 satellites out there in different orbits around the Earth. There are some on the lower Earth orbit, which is probably most of them, over maybe 3,000 or so. And there are some in the geosynchronous orbit, which are more in the probably around 500 to 600 of them, and some kind of in the middle. They have a variety of functions. Some of them look up to the heavens, try to give us better pictures from the galaxies and all that. Some of them look down to Earth for Earth observation, and some are here for communication. So they're trying to help us communicate better, have better coverage and better service. And remote sensing is one of the applications, looking at the forest, looking at the water bodies, and of course tracking different things in the orbit and all that. So it's a very diverse market up there.
Who oversees all of this, or does anybody? One particular entity?
So there are a variety of different agencies that they look at them. Some of them are sort of related to the countries. For example, U.S. has its own Federal Communication Commission that basically gives all the licenses and all that. And then there is a international committee that looks at the overall allocation. It's called ITU, International Telecommunication Union. And of course, depending on what those satellites do, if they have cameras, they're looking down to Earth, then you need to coordinate with NOAA. So there is a variety of international bodies that they oversee those. So.
Joe, what are CubeSats? What is that the next generation, and what can they do that other satellites can't?
So CubeSats are a specific form factor for satellites. So they're based on small units of 10 centimeters squared or cubed. And they were invented in 1999 at Cal Poly, I believe. So because they're small, they actually oftentimes have less capabilities than large multi-million-dollar spacecraft. But because it's a standard form factor, they're actually cheaper by orders of magnitude than large spacecraft. So although they oftentimes have less technical capabilities, because it's a cheaper mission, you can assume a lot more risk. So, for example, you can try more novel technologies. In our case, you can have students working on them, and it can really be an educational engineering experience.
So your project is called MESAT or MESAT-1. How did it come to be? What is the overall mission?
So we call this MESAT-1. So Me stands for Maine, and satellite for satellite, and one because this is the first small satellite we're developing in the state of Maine and launching to space. And basically the mission of the space, as Joe was mentioning, is for CubeSat, we want to provide access to the space data to ordinary people like high school kids and teachers, undergraduate and graduate students, and also the industry in Maine. As Joseph was mentioning, the traditional large-scale satellites or multi-million-dollar satellite, it takes a long time to design, launch them, and then get access to that data is extremely expensive. With a smaller CubeSat, which are much lower cost, you can launch them much frequently. You can provide much lower cost data, which will help different businesses across the state. In our particular case, we are looking into monitoring water bodies, looking at the concentration of phytoplanktons, looking at harmful algal blooms. We are also looking at urban heat islands to consider energy efficiency and things like that. So basically, this is called the new space economy, trying to go away from just this few monopolies that they own a few big satellites and they sell at the price they want. Rather, we can have this open to the entire state. Anybody can design a satellite, and hopefully in near future we'll have launch capabilities in Maine, and we can also launch them. So that's kind of democratizing the space basically for people.
Joe, how specifically are schools involved? Did they generate some of the ideas that the satellite is going to gather information on, and how will they use the data that's collected?
Yeah, so actually one of the main thrusts of our mission is that middle schoolers and high schoolers across Maine actually designed the science mission. So our job here was just to do the engineering for them. But, we sent out a call for proposals, and the winning proposal, it was their idea. They wanted to look at harmful algal blooms. They wanted to look at urban heat islands. So we're just doing the engineering to get that data for them. And once we go into orbit, hopefully, cross our fingers, everything works, then we'll be able to deliver that data to them, and, they can do whatever sort of science they want.
And what schools are involved?
So we have Falmouth High School, Saco Elementary School, Saco Middle School, and
Freiburg.
Freiburg Academy.
Great. What does it take to launch one of these satellites? And as you said, it's a lot cheaper, but how do you get them up there?
Yeah, that's a good question. There are a variety of ways to do that. There are some commercial private companies that they can do that for you, or you can go after federal companies like NASA to be able to help us. So we applied for the CubeSat Launch Initiative program, which NASA runs, and then they basically hire some rockets that are built by commercial companies to send the satellite up there. It takes a few years to actually design and build and test all the different pieces of the satellite, but then you have to go through a very detailed series of flight certification through NASA and some of the companies that they work for them. And once it's ready, we'll integrate into the rocket. They will launch it to the lowest orbit. And when it comes to the place that they're going to be released, there are dispensers, and they basically release the satellite right there into the proper orbit. So it's an interesting journey for a few years to kind of get it done. But we hope that with the new SpacePort Corporation enacted in Maine and a couple of launch companies working here, maybe we can do this much faster and much more frequent here in Maine, hopefully in near future.
Now, we've talked on a previous episode about some of your wireless sensor work. How is that involved in this? And is this a natural progression for doing more work in that area?
Absolutely. I think going back to that podcast or interview we talked about, I think we were talking about the wireless sensors for International Space Station when we started to do the leak detection. In some sense, that was difficult because our first time launching something to space, but in some sense, compared to this, it was a little bit easier because that was going to be inside the space station, no radiation, no temperature fluctuation. So we had much less stringent engineering conditions to overcome. Now we are taking that to the next level. So we need to build sensors, systems, power systems, and batteries and all that you need to keep them at a good temperature. So for example, we have heaters on our batteries when they're in space. So the battery has to use its own energy to heat the heater to be able to keep the battery from going. So you have to optimize this very carefully so that you don't run out of battery because your system gets frozen and you can't really recover from that. We need to make sure our device is completely shielded, so the radiation and all that. And it's not installed inside the space station as we had in the previous case. This is going to be floating in a space. So we need to have a way to control it and also be able to command it and also get the data off of it. So
what your wireless sensors are, what are they sensing specifically? Is it the urban heat islands and the algal blooms?
So in this case, we have 4 different multispectral cameras on this. So they're basically sensing different wavelengths of the visual light spectrum. So we have like infrared, green, blue, red, all those different wavelengths in light. So those cameras will sense that. And then we collect the data, we process it, become digital data. Then we have 3 radios on board. So those 3 wireless radios are UHF, VHF, and also we have a global star radio. So they will receive commands from Earth, and then they will send the data back. And also they connect to the global star satellite network as a backup. So in case one of these links doesn't work, we still have some kind of other backup. But basically we are imaging in a specific wavelengths.
Joe, maybe you can give us a little satellite 101. How are they deployed out of the rocket? How are they controlled? And how does the data, I guess, as Ali explained, it's radio that sends the data back to Earth, right?
Yeah, so with CubeSats, it's actually sort of interesting. The CubeSat is compressed into a container that they call a P-pod dispenser, and it's actually spring-loaded. So when the rocket enters the orbital plane that we want the CubeSat to be in, they open the latch and the spring just kind of shoots the CubeSat out. So it's very low tech, but reliable stuff. So after we're in orbit, then like Dr. Betty was saying, we basically use radios to command the spacecraft. The spacecraft has radios to send back telemetry and health data and science data to us so we can sort of get a picture into what's happening aboard the spacecraft and command it accordingly.
Right. Ali, over the last couple of years, UMaine has become a lot more involved with NASA and NASA projects. Can you talk about that and what's the evolution of that and where's it headed?
Yeah, that's a good point. I think a few years ago when we had a new vice president for research here, Dr. Kodi Vahramian, he started this new initiatives on campus to basically break the silos, to be able to have people from engineering and sciences and arts and humanities that all work together. So one of these initiatives is called UMaine Space. And through UMaine Space, we have been able to invite speakers, program directors from different NASA centers here. We were able to have a better infrastructure for everybody across campus from different disciplines to be able to submit NASA proposals, and that has created some momentum. So now we have more and more NASA research here. We hope that with this sort of critical mass of researchers working on these different programs, we can expand our portfolio of space research across a variety of disciplines. What's interesting is that for many years people were thinking, okay, NASA is just about engineering. It's not. I mean, there is lots of different sciences, from social sciences to natural sciences to physical sciences, and thinking about arts and humanities. They also have done a tremendous amount of interesting work here. Our own student, undergrads, grads, and faculty in a space-related stuff. So we need to, of course, design some missions. You need scientists, and then you need engineers to build instruments to be able to achieve those objectives of science. But you also need to communicate that to the public. You need to also communicate all those complex systems. You can communicate by words or equation, but most likely communication by podcasts like this, like voice, or maybe images or videos or sculptures, things like that, will help people understand these comments. And then this is a sort of a cycle, going from something that we can see, something we cannot see, and then grab that imagination that we have and come back and build something that we can use here today on Earth. So there's a lot of offshoots from the space program that we enjoy today that many people even don't know they started from a space program.
Right. How did you both come to this work? What sparked your interest and what sort of led you down this path? Joe, maybe start with you.
So for this particular project, I actually heard about it through one of the professors who was teaching a course. He said, this guy, Dr. Elliot Betty, was building a CubeSat, a small spacecraft, and he needed help. And I just thought that was the coolest sounding thing ever. So I came straight to his office and applied to work on the project. So I just thought it sounded really cool.
But is this something just generally that, since you were a kid, you wanted to get into?
Oh, yeah. I've always loved electrical engineering, solving hard problems and, using math and that sort of thing. So, yeah, I've always been interested in this sort of thing.
How about for you, Ali? Same story? This has been since you were a young lad? Or
Yeah, I think every kid has been interested in space. My sort of point that I remember was when I was in high school in the mid-'80s, the Challenger accident happened. And I read that in one of the magazines I was reading and said, it looks like that we need to do a lot of work to make the space travel more reliable and safe. So from that moment, I was kind of thinking that maybe I should get into the space exploration and all that. But of course, it takes a long time until you go through engineering school and get to a point you can actually submit proposals and all that. But I'm happy that we are just making a small dent in the space community. So that keeps us going.
For here at the university, how are UMaine students involved, and will UMaine students work with this information and benefit from all this activity that you're doing?
Of course. The students who have been working on this process in terms of like building and designing CubeSat, of course, they see firsthand how the hardware and software works. The students who will get access to the data, no matter if they're from engineering program or from sciences, they will all get actual real data from a space, which is much better than simulated data or outdated data that sometimes in some of the classrooms they might have seen in the past. So we try to revitalize the entire sort of training and education opportunity for the student so they can see they have live and real-time data to practice their analysis. It will affect different fields, like from artificial intelligence and machine learning. You can go through this data and figure out what's going on. And other than Maine, of course, like University of Maine and of course high schools and middle schools and all that, other universities are approaching us, like Northeastern University, like Rue Institute, important. They want to get access to data for their data analytics program. And of course, other states can also have access to this because this satellite is not just going to be hovering over Maine. This is on a polar orbit, so it goes all over the world. And everybody can have a little bit of interest to kind of use that. And I think at the end of the day, my sort of goal is that for the students who are struggling with basic science courses like physics and chemistry and calculus and biology, when they come and see this project, they realize that why we are teaching them those tools. So kind of give them a purpose and maybe help with our retention and just getting more students ready for the workforce.
Nothing replaces the cool factor of something like this, right?
Absolutely.
Yeah.
Yes.
Joe, I don't know if are you working directly or have you interacted with any of these middle or high school kids, and do you see that spark in some of them when you talk about what you guys are doing?
Oh, absolutely. Especially with the Falmouth High School kids, we worked very closely with them at the beginning of the mission, and even now, just trying to understand their specifications, like what kind of science data are you hoping to see and what are you hoping to do with it. And it sparks so many engineering projects at their high school. They're interested in CubeSats, they do 3D printing, they're interested in programming now and soldering and building circuits and all sort of things. So it definitely has sparked some curiosity there.
Yeah. One of the more exciting aspects of this seems to be that the space industry in Maine is growing and is a thing, I guess. Where is it now? What is the potential? Is Maine a good place to do space-related work? And does it have the potential to grow companies and provide jobs?
Yeah, Maine is famous for its craftsmanship, right? We build ships here, the best ships in the world. When you go to Bath Iron Work, it's like written on the wall that we made the best ships in the world. Spaceships are the ships. The only difference is that they're not in the water, they're in space. So there is a large number of very high quality aerospace and space manufacturing companies in Maine that you can't count with your hands. And there are a couple of launch companies, Blue Shift Aerospace and Vault Enterprise, that they are also into this market with very unique and interesting technology. One is using organic rocket fuel. The other one does not carry oxygen on board and uses the oxygen in air. So we call them air breathing ramjets. So those are very promising in terms of the infrastructure. And then there is a lot of R&D going on here, of course, at University of Maine and our partners in other campuses, University of Southern Maine and others. And more recently, the Maine SpacePort Consortium led a group of us to kind of talk to each other, and then we went to the legislatures and we got the Maine SpacePort Corporation approved and signed by the governor. So now we can actually have access to economic development funding and more sort of federal and state funding to actually foster this collaboration. And why Maine is good, other than existence of all this infrastructure, is that we are the most northeast location in the country. And in order to get to one of the best orbits around the Earth, which is polar orbit, we have the best capability to actually get to the polar orbit, which takes less energy from here compared to like equator that is good for the geosynchronous orbit. And of course, we also have a lot of land here, which is unoccupied, like we can launch horizontal launch over the ocean and all that kind of stuff. So there are a lot of attractive sort of features for a spaceport to be here. And I think that will change the Maine's economy.
So we'll see more jobs as a result.
Absolutely, yeah. Way more jobs than we expected, because there is a lot of supporting industry around space and aerospace as well.
So as we wrap up here, what's next? What's on the horizon? What kind of developments might we see? What projects might be coming down the pike that you're both excited about?
Yeah, so after this is launched and we kind of get the data in our ground station here, we already have another project funded in collaboration with the civil engineering professor, Dr. Honor Apul, to launch nano bubbles into space and monitor their behavior. So we are excited about that. That's called PineSat-2. So that's our second satellite. And literally last week, we just submitted the third proposal to NASA. And if that gets funded, that would be called QCSat-3, and that stands for Quantum Communication in Space. So we are going to test new methods for high-speed communication that is not possible on Earth today. So we're excited about continuing this. I think UMaine can be a leader in terms of satellite manufacturing R&D in the state of Maine. And once the companies who want to join the spaceport come here, we'll be able to provide workforce for them, provide R&D services and all that. So I think this is just the start of a very interesting era for us.
Joe, where do you hope this takes you once you finish your PhD?
So once I finish my PhD, I think I'd like to work at NASA. Right now, the research that I do is through NASA, I mean, as well as the CubeSat, and I think I'd like to continue that work once I graduate.
Well, exciting stuff. And the launch is set for?
Late January for now. So
if all goes well.
Hopefully the weather goes well, right? So.
Well, exciting. Appreciate you taking the time to talk to us.
Thanks for having us.
Thank you.
Thanks as always for checking us out. You can find all of our episodes on Apple and Google Podcasts, Spotify, Stitcher, and SoundCloud, UMaine's YouTube, Twitter, and Facebook pages, as well as Amazon and Audible. Send us a note if you have a question or comment at mainquestion@maine.edu. This is Ron Lisnett. We'll catch you next time on The Maine Question.